got this here question for you. I'm 1 minute early, and I'm totally getting a little bit of echo because I left my computer volume on. Oops. Hello. Hi, Aspen. Wonder if we're going to see a couple more faces now that attendance in this is correlated with actual grade stuff, which is good. Oh, I should post that link in chat. I am limited to grading only or assessing at maximum 45 minutes per class period, so an hour and a half a week. Sorry, I skipped the last two streams. I was playing Animal Crossing. No worries. Good news is, if you skip them, you can still watch them because they're posted on my YouTube channel. So as you're preparing for the AP tests, you can always check that stuff out, and that is no issue. So what was I posting? This link. Oh, no, I'll post it in a bit, since I don't want people filling it out before they actually, do things. Hello, hello, I have this practice question for you. This is a calculator aloud question, or a Desmos aloud question, or whatever you want to call it. Regarding mosquitoes, and answering A through D for these mosquitoes. Hello, hello. Welcome to those of you who just showed up. We are in the calculus window, thankfully. I was able to keep things about the same. If you're watching this later on YouTube, don't worry if you're watching it late and you can't attend the live stream because you have another class third period or whatever. I post these all so you can watch them at your convenience. I recommend watching everything that I have done so far, because every single stream I've done so far has been a review stream, so if you missed it, it's helpful to try the questions yourself, pause the video, and then zoom to where I go over it if you want to see how to do things. So that might be a good strategy for those of you who may have missed this, or are just coming back to calculus. And I feel bad for you if you took a month off calculus, because rip your abilities. So, hello Ivan, hello Keith, hello Chelsea, hello Kelly, heyo Margaret, hi Rose, Daikun, and Sam. Welcome, and try out this free response question about Tropical Island. Hello Matthew and Andrew. And if you missed it, everything we've done so far is review. Everything we're doing is review. If you are just showing up and you have not attended any of the other or watched any of the other live streams, know that everything we've done so far is probably useful to look at if you're looking to review. Hey, Elise. I should actually do this question because I haven't done it yet. I found it. Hello, Natalie and Caitlin. Welcome, welcome. Hello, Marco. That first A on this is not a high bar, just a little hinteroonie. Assuming you have a calculator or Desmos, you should be able to do it. Hello, Dylon. Hello, Andre. Goodbye, Sanjana. I know Kids Bop is bopping on. Wait, that's Wednesday. No, you have no reason to not be here. Oh, unless you haven't. Wait, are you in third period? Aren't you? Crud, it's been so long. Yeah, you are. You have nothing else to do. uh, yeah. I know you're in third period. Uh, at least I was able to figure it out. I think this is actually easier to do on a calculator. So far, that has been my take on it because I am not great at typing all this into Desmos. So weird. Usually I think Desmos is easier. If you haven't been to any of these, let me know when you are done, and when enough people are done, we go over it. So I am expecting you to work on this right now. I am not like just trying to desperately finish here, so I can, tell you how to do it. I'm finishing it just to see how I would do it on the computer. And man, if I was a technical wizard, I would totally get the ability to switch between my desktop and my tablet, because that would be nice for my stream. But that seems like a lot of effort. Cool. I think I got it. Let me know when you have it. Usually go about 15 minutes because that's how long these questions take on average. If you haven't heard, the AP test is going to have 2 free response questions and is going to be about a 45-minute AP test. It's why we're focusing pretty heavily on free response questions. We do that anyways down the stretch because we do multiple choice a lot during the year. You guys missed 1 or 2 multiple choice tests before the AP test here. And since we're not going back, you've no longer have any tests left except the AP tests. So that's kind of cool. uh, I mean, I could test you if I was obsessed with the assessment. We'll probably figure out something test-wise if we're actually giving letter grades, but we're probably not giving letter grades. We'll see. Not even a final. Well, just like the AP test, how do I make sure, at least, that your tutor or that your friend or that sort of thing doesn't take it for you? I don't really like the lack of accountability, so it doesn't feel good to give grades for that. So I'm hoping we go to the pass-fail, just in general, so I can just give everyone a pass who did things. So, yeah. I'm surprised it's even an open discussion at this point, but whatever. I'm sure they're panicking like crazy because there's a reasonable chance, hey, juniors, you might not have a lot of school next year. It might be a lot of this. It kind of depends on when that vaccine comes out. High school Mr. Kennedy would not have cheated on this. Besides having like notes in the room with me when I was taking it, which I don't think is even cheating, because A was too lazy and B was actually curious what I knew. I've always had that wiring when I take tests. I'm more curious about what I know than what score I'm gonna get, which I guess makes me weird. Alright, up to 2 duns, but usually we wait for like 8 or so before we move forward. How is the grade situation not finalized yet? It's a good question. Good news is Washington is the poster child for how to do the quarantine right. Thank goodness for the fact that we have so many tech jobs that can work from home in Washington. That's really probably the main reason why we have done well. Uh, I mean, if they're throwing out their principal said, oh, really? Huh. Well, if Skyline's going, I figured we were like 95% pass fail, 5% chance of grades even like 2 weeks ago. So, yeah, most likely we're doing pass fail. So I agree with that. Uh, the Skyline principal probably was given some leeway in the decision. Our principal will probably follow along, knowing his general train of thought. Uh, Pass fail is the better option for sure. Uh, if they're throwing out what is it the SAT and all that for college admissions, which by the way, the Mr. Kennedy hypothesis on that is colleges are a little worried about enrollment in the next few years because this is pretty hard on a lot of families' financial situation, and a lot of college funds are probably going to go to buying groceries and paying rent uh, instead of going to college. So part of the reason they're dropping SAT is demand is probably going to shrink. So they had no issue doing that for that reason. Oh, how does pass fail affect your GPA? It's literally just it doesn't change it. Your GPA, if you pass every class, your GPA coming into second semester is your GPA at the end of second semester. If you fail, you just are credit deficient, so I think your GPA doesn't matter anyway with pass fail. Uh, I'm not sure about that though. We are up to 5 duns, just a couple more, and we'll probably be going over this, which should end up right around 15 minutes in, which is perfect. Chelsea, if we go to pass fail, which they have not emailed at Liberty about yet, uh, then yes, your GPA would just be your GPA coming into second semester. And pass-fail just affects credit. So there are some people who could fail calculus still, um, by not doing anything during this stretch and not having fantastic grades coming into the stretch, which literally the bar for doing things for the next like 2 months is real low, like very low. So shouldn't be an issue. Am I going to use teams at all? I'm still kind of undecided on that. Being as how I can only assess 45 minutes of work a week, I'm not sure it's worth it for me to ever assess your work. So I'm not sure that I need teams. So I'm a little undecided on that one. Uh, if we don't do pass-fail, can we retake quizzes? I'm gonna have to figure out a lot more than just retaking quizzes if we don't do pass-fail. That I'm a little bit picnic if we don't do pass-fail. All right. um. Is the factor with pass-fail? Yeah. Uh. Again, things are kind of complicated because there are a lot of liability things between the decisions the district and the union and all that made. And so my hands are tied in a lot of ways for what I'm allowed to assess, which is why I don't think it'd be very hard for them to make me give grades, which is weird. But I put everything in Skyward, so it should be obvious that you're pass or fail or whatever. And I'll be having conversations if people are in the fail category. Anyways, I was going to go over this question now. For A, all you do is plug in 6 for t in this equation. If you plug in 6 for t in this equation and you're in radians and not in degrees, you should have gotten like 4.438 as your rate. So that means the number of mosquitoes is increasing because that number is positive. If that number was negative, we'd have a decreasing number of mosquitoes. So this is the bad case because increasing mosquitoes is bad. I hate mosquitoes. Okay, B. At time t equals 6, is the number of mosquitoes increasing at an increasing rate, or is the number of mosquitoes increasing at a decreasing rate? There are a few different plays for how to do this. The easiest one is to graph this. If you graph this thing, it looks something like this. Doink. Like something like this, and then it goes on because time ends at 31 in this problem. But anyway, 6 is right here. And if you look at that spot, it is positive. That's 4.438, the height of that point. But it's going down. So the number of mosquitoes is increasing at a decreasing rate because the rate at which it's increasing is going down. And so that would be, I mean, you could use a picture for your reason for this. I also graphed the second derivative, and it was negative and all that kind of stuff. There are a few different ways to go about doing this. But the point is, it's increasing at a decreasing rate. And again, the graph is a good explanation of this. If you sketch this graph, said, hey, this is t equals 6, and show that it's going down at that point, that's good. For C, how many mosquitoes will be on the island? All I did was I said there are 1,000 mosquitoes at the starting time, and then my change in mosquitoes is the integral from 0 to 31 of my rate. 5 root t cosine t over 5 dt. And if you do this integral, you should have gotten that there are, and you're rounding to the nearest whole number, so there are 964 mosquitoes at the end of this interval, at the end of the month, I assume. I dropped my pen. Hopefully it's still cool. All right, D. To the nearest whole number, what is the maximum number of mosquitoes on the interval? And I just realized I solved for the minimum in my integral, so I'm going to fix it here so I can tell you the number. The good news is it's not much more than 1,000. This rate is pretty small, and so it doesn't actually affect the number of mosquitoes a ton. But all you have to do to find it is, going back to my graph here, since this is a derivative graph, it's a rate graph, the zeros are my critical points, so my possible maximums or minimums. Or the endpoints could be. So my possible points are, let's draw this up a little more. 35 happen or 31 happens like right here. So it could be at 0, at this first point where we go through 0, which is 5 pi over 2, at the second point where we go through 0, which is 15 pi over 2, and at the last point, the end of the interval, which is 31. So all we have to do is test and see which one's bigger. The end of the interval, which we can figure out here is 964 mosquitoes. So it's not that, because 1,000's already bigger than that. So 1,000's currently our league leader, according to what we know. So we chuck out the last endpoint, because that one cannot be it. So that leaves 5 pi over 2 and 15 pi over 2. 15 pi over 2, we switch from decreasing to increasing, so that's trash. That's a minimum. So 5 pi over 2 is our boy. We just got to figure it out. So you just integrate 1,000 plus the integral from 0 to 5 pi over 2 of your rate. And if you do that integral, you get 1,039 mosquitoes, and that is our maximum. So anytime you're trying to find the maximum or minimum, you have to check not only the critical points, but also the endpoints. Luckily, we had already done 2 of the endpoints. One was a given, or the 2 endpoints. One was a given, 1,000 mosquitoes at t equals 0, and the other one we solve for and see at the end time how many were there. And so we got there. Daikun, when you say no, you do that, that's exactly what I did, so that's good. Is this not kecked because there's an interval? This isn't kecked because it's not a differential equation specifically. It's kind of one, in that we're given a rate, but we don't really need to mess with differential equations. We're just doing these initial condition plus the integral sort of pieces to get the number of mosquitoes. And so we don't have to worry about that. Calculator is always in radians. I know in physics sometimes you use degrees, but in calculus it's always radians. Always, 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 always. All right. This is so cute, 100% like I haven't done this since Unit 2. Oh, well, good we reviewed this stuff, I guess. I guess a lot of this is not from Unit 2, though. Interesting. Okay. Just a little bit about how things are going to go. Monday and Thursday, we're going to do 45-minute streams. 45 is kind of the minimum. If you want to stay longer, that's cool. These are the practice pieces. I'm going to give 4 assigned free responses as recommended practice. So I have those posted on my calendar as is, like right now. You should probably practice more if you want to get better. I sent out an email and put something in Skyward saying that. How do you log into this live stream? I'm just having a Google form. Whoops. I copy-pasted something else, so now I have to come back here. I'm just going to have a Google form because I like spreadsheets. And so this link that I just put in chat will bring you to one of those. It asks you if you watched half an hour, so none of you should be filling it out yet because that's not possible. Haha. But that's how the attendance will work for this. That attendance will work ex post facto after this. So if you are attending this on YouTube, you should find a link to the attendance form in that, and you can do that as well. And so no problems if you can't make these. So we're doing these on Monday and Thursday, 45 minutes. I forgot to put on this slide that there's actually Wednesday. We're doing what used to be the Friday streams where I don't actually assign any practice or anything like that. We just mob questions for an hour, and that's going to go from 2 p.m. to 3 p.m. I know it's going to overlap with stats, so sorry, but I mean, the good news is I post everything as VODs, so you can miss it and watch it later, and that's no problem. That link is the homework. Yeah, you're right. Okay. Uh, can I link the right thing? Am I smart enough? Do I have it open in my tabs? Yeah, this here. This is the second one I posted here. That would be the survey thing. AP Classroom has the optional student practice next to your assignments now. Dope. Dope, dope, dope. That's fantastic. So definitely pursue that. I am only allowed to assess an hour and a half of your material per week. So I'm very limited. And so I'm probably going to be mandating that you watch live streams. Sometimes I'm going to be maybe collecting homework or that sort of thing. They're all FRQs. Fantastic. But yeah, that's kind of how we're moving things right now. Seriously, if you have not already, check out the Green Barons book. If ever you're feeling like, hey, I should do a little bit of calc practice, just open that thing up. You can go by section, so you can skip the area and volume section. Or you can just open up to the end, and there are 4 AP Calculus AB practice tests. Don't do the BC ones. Well, you can do the BC ones, you just won't know how to do a third of the questions. Can you assess it and put it in as an uncounted category? I'm still a little undecided. Yes, I can. I just need to make a way for you to upload that. So I'm still trying to figure that out 100%. And yeah, Akarsh, you can find all the details on the AP website if you want to know a lot more about it. I don't have them ready right this moment and don't remember them exactly, but basically like one long free response, one shorter free response, like normal size free response. I'm going to figure out some sort of, oh yeah, something else for plan of attack. I'm going to figure out some sort of mock exam. I can probably figure it out through AP Classroom. That will be happening next week, so it might happen in lieu of a stream. We just do a mock exam, and maybe I have a video going over it, or like a stream going over it, or something like that. But that will happen next week. I'm going to figure out the logistics for that. But that will be within our normal scheduled content and that sort of thing. How are we going to show the homework to you? Are the questions in AP homework? Okay, so this day's homework is AP questions. You can just write them down on paper, that sort of thing. So that first link I gave has those questions in there, and if I collect that, I'm going to be collecting it as pictures of your work. Same way the on's up there. Okay. Last question before we move from plan of attack. I'm technically only allowed to assess whether or not you're here for 45 minutes or so. Would people be interested in me going longer today? Because I do have more stuff to cover available. Is there anybody who's like, nah, 45 is the end, or anything? Or are people okay with just going and going until we're good? Liam's like, no. And everybody else is like, sure, go longer. Yeah, if you have AP laying at 2, feel free to go away and come back. Just like try to remember the timestamp so that when you come back, you look. Are we getting passes for completion? You're getting passes for completion at this point. Yeah. Okay, cool. So we'll just keep covering things and go past the time because whatever. I have Calc 4th period too, so it's not like I can get in trouble for stepping on hands here. All right, homework review. This is, for those of you who don't know, I have been assigning homeworks. Where is it? It is this one. Uh, 4-8 homework. Is this the right homework? Let's look. Oh man, that was so long ago, it tripped me out with the date. Spring break was really bad for me. I got food poisoning and stuff. It sucked. Uh, Alright, this is an old test question here. Just a little differential equation here. So I'm just going to chug through like three free response questions. If you haven't done these yet, you could do them, or you could just watch me do them and try to pick it up. Okay, if you separate variables with this equation, you should have gotten dy over y squared by dividing the y squared to the other side equals 1 over x minus 1 dx. Now, for some reason I'm doing C in A. I was supposed to do a slope field first, so I'm just going to back up and do the slope field. I just get so excited about solving these, and many of you do too, and just skip straight to that. I'm going to sketch this here slope field. Wait, 0 is -1? Yikers. All right, the bottom's -1 for all the x equals 0s, so that makes it just 4 over -1, and -1 over, or 1 over -1, and over here, if we plug in 2, the bottom's always 1, so I just do 4 for 2, 1 for 1, and when y equals 0, the slope is always 0, so these are flat lines here. And so it looks something like that. For B, it says we have this initial condition, 2, 3, and we're writing a tangent line to the graph at x equals 2, so at 2, 3. So we just plug 3 for y into our differential equation, so we get 9 on top for 3 squared, and 2 minus 1 on the bottom. So we get 9 as our slope, which honestly would have just been the next piece in our slope field. We could have figured that out. It's just 9 slope there. And now that we have the slope, we just do y minus y1 equals slope times x minus x1. Dope. Done. We could add 3 to the other side and get y equals, what, 9x minus 18 plus 3, so minus 15. And then to approximate f of 2.1, you just plug in 2.1, and 2.1 times 9 is 18.9. 18.9 minus 15 is 3.9. Last piece is I gotta actually solve the differential equation, so that's what I was excitedly doing right at the beginning. So let's finish mobbing this thing. If we integrate dy over y squared, we get -y to the -1. If we integrate 1 over x minus 1, we get natural log of x minus 1 plus c. Now, I skipped over this one and did this one kind of fast. In my head, I always rewrite dy over y squared as y to the -2 dy, and that's how I'm able to just raise the power by 1, divide by the new power, y to the -1 over -1. But please be aware that you don't use natural log for this guy. You have to use just normal power rule. Otherwise, you're going to be a little bit sad and do those a little bit wrong. Okay, so then we just multiply both sides by a negative, and we get 1 over y, which is y to the -1, equals negative natural log of x minus 1, plus a different c, because we don't do minus c. I can take this negative and actually warp it inside as a power of this absolute value of x minus 1 piece. And then I can just flip both sides, and I get y equals 1 over the stuff that was on the right there. So that's natural log of 1 over x plus 1 in absolute values, not parentheses. Because x minus 1 to the -1 power. I don't know why I put it in there. I don't think you need to. I think you could leave it as a negative in front, but I did that this time. So that's interesting. So totally legit if you got this. Y equals 1 over negative natural log of x plus 1. This is exactly the same thing as what I just did. And then all you have to do is find plus c. So you just plug in 3 for y and 2 for x. Whoops. So let's do this where I have a little more room. Y equals, I'll use this one. 1 over negative. Did I switch my minus plus 1 to a, gosh darn it. That's a minus 1 in there. That makes plugging in 2 way nicer. Natural log of okay, x minus 1 plus c. If I plug in 3 and 2, I get 1 over negative 1 plus c, or negative 0 rather, because 2 minus 1 is 1, natural log of 1 is 0. And so all I get is 1 over c equals 3, so c is 1/3. And it should be the same in either of the cases. If you plug a 2 in here, you get natural log of 1, so it's 0, and you get 3 equals 1 over c here as well. And so you get c equals 1/3. And that makes the final answer either of these guys, just with c being a 1/3. So 1 over negative natural log of x minus 1 plus 1/3, or natural log of 1 over x minus 1. Yeah, Jack, I can't really do anything like that. Basically, do all the work that I've given. It's honestly not that much, and you should practice for the AP test doing it. And you should have no issue at all. As I know how we're grading second semester, I'll be able to provide more feedback. I don't really know. Isn't there a negative on the bottom for the C? There isn't a negative for the plus C. If you had, oops, my power cable fell out. That's bad because my Surface is almost dead. So if you have a negative C in this question, then you will get a negative 1/3 for your C, but you end up with the exact same equation as me because you subtract negative 1/3 C. So it should work out the same to be this equation no matter how you do it. And this was a test question I gave in class, actually. It might have also been on an AP test or slightly edited from that. But yeah, if you were in class, you would... Crud muffins. I just closed the entire homework. Why am I so bad at everything? All right, good news is I have my keyboard plugged in, so this is fixable. Okay. Yeah, holy smokes, I got food poisoning eating some food. This is my first day feeling normal in a while. Oh man, that was a miserable experience. So if this class was 2 days ago, I wouldn't be having it. Alright, I'm back to this. So let's mob the second one. Okay, so the first at-bat in 6 here said just find the derivative and find the second derivative. And if we do that, we get 1/2 k x to the negative 1/2 minus 1 over x. That's f prime. And f double prime of x is negative 1/4 k x to the negative 1.5 for bringing down the negative 1/2. And then 1 over x is x to the negative 1. So we're actually going to get a plus x to the negative 2 because the negative 1 comes down and kills the negative. So boom, derivative, second derivative. There was actually no chain rule required here. This was just simple power rule with a little bit of natural log in there. What did I eat? Something expired. I'm not 100% sure what the cause was. Feels bad. For what value of constant k, does f have a critical point? So to find critical points, we set the derivative equal to 0. So what we do is set this equation equal to 0. Now we're testing to see what value of constant k makes it have a critical point at 1, so we plug in 1. The 1 over the square root of 1 is 1, so it's just 1/2 k minus 1 equals 0. This is pretty easy to solve for k. If we add 1 to both sides, we get 1 equals 1/2 k, so k is 2. Okay, for this value of k, determine whether or not f has a relative max, a relative min, or neither. So what we do is we plug in 2 back into our in for k in our equation, and we get this equation: x to the negative 1/2 minus 1 over x. And our critical point is 1, because we said that was a critical point. So all we're going to do is test values on either side. If I plug in, I don't know, 0.1 and 2 into this, I can test and see whether or not it goes from increasing to decreasing or decreasing to increasing, which is how we always test for relative max or min. If I plug 2 in, I get 1 over the square root of 2 minus 1 over 2. That's negative, because 1 over 2 is big. Or wait, no. 1 over the square root of 2 is 1 over 1.414. Minus 1 over 2. Oh, that's positive, because this is bigger than a half. So we're actually increasing afterwards. If I plug in 0.1, I get 1 over the square root of 0.1 minus 1 over 0.1. The square root of 0.1 is bigger than 0.1. So we actually get 1 over something bigger than 0.1, so like 0.3-ish. And 1 over 0.1 is 10. 1 over 0.3 is like 3.5. And so 3.5 minus 10 is definitely negative. We probably could have picked easier values to test. I'm not 100% sure what they would be, but the big idea is that it's negative before and positive after, so this is a minimum. Can you do the second derivative test for part B? Oh, yeah, that's like real smart. Yeah, okay, so I did the increasing decreasing here, which actually works totally legit. But we could have also done the second derivative test, so let's give that a try. If I plug in 2 for k, because that's my value that I figured out, I get negative 1/2 times x to the negative 1.5 minus 1 over x squared. And you can just plug 1 into this, so you get negative 1/2 minus 1, or plus 1, whoops, that's a plus, which is positive, 1/2. And if we're positive, we're concave up, so if we're concave up, it's a minimum. And so that is a different way of doing exactly what we did here. Both of these are legit and would have been acceptable ways to solve this, either doing the second derivative test or doing the first derivative test. So good point out. They're both legit. I can't see a reason why you should. Maybe the numbers are easier to solve plugging in 1, so the second derivative test wins out for easiness. But both legit. So yeah, thanks. Good point out. For a certain value of the constant k, the graph of f has a point of inflection on the x-axis. Find this value of k. Oh, crud. I just deleted my second derivative. That was not a good move. Edit, undo. Hey, okay. I want to erase this instead of deleting, because I need to use the second derivative here, because I'm talking about a point of inflection. Okay, so the first piece of information that's like critically important here is it's on the x-axis. So what we know about that is we know that the value equals 0. So we know the y value equals 0. So we know 0 equals k root x minus natural log of x. This is really helpful because it helps us solve for what k is. And so we can plug that into the second derivative, and then there's only one variable in our second derivative for which to find an inflection point. So if we do that, we get natural log of x equals k root x, and we get k equals ln x over root x. Now that you have this, you can just plug this in to the second derivative here, and we get negative 1/4 times ln x over root x times 1 over x root x, which is x to the negative 1.5, plus 1 over x squared. And the schnazzy part about this is root x times x root x is just x squared. So we get negative 1/4 natural log of x over x squared plus 1 over x squared. So we can take out the 1 over x squared, and we get negative natural log of x over 4 plus 1, and we can solve this for where it equals 0. So we just solve for where ln x over 4 equals 1, so where ln x equals 4, so it's x equals e to the 4th. So that's the point at which this happens. Now, this isn't what the question's asking for. The question's asking for k. So I can't just stop here. I have to go back to my k equation, and you get natural log of e to the 4th over the square root of e to the 4th. And thankfully, these like simplify really easily. Natural log of e to the 4th is 4, and square root of e to the 4th is e squared. And so, booyah, 4 over e squared is the value of k. So that was a pretty heavy question. That was, that C there was hard. A and B, pretty easy. Just power rule, just doing some basic test stuff. C took some nuance. We had to start here, we had to figure out the point of inflection, where it happens, and then we had to go back and find the value of k. That makes it a point of inflection. All right. Last one. This one's easier in my opinion. So, estimate the radius of the balloon when t equals 5.4 using the tangent line approximation at t equals 5. Is your estimate greater or less than the total value? Okay. So, how to start this question? We know some things about this. We know the radius of the balloon is 30 feet, so this is going to help us anytime we're doing integrals. So we're talking C or D. That's going to be really helpful information. We know some more stuff about this. We know it's twice differentiable, which means all of our calculus works. That is a hint that every single one of our rules works. The mean value theorem, the intermediate value theorem, all that junk. It means the derivative is continuous, it means the second derivative is continuous, and it means the original function is continuous. We also know this thing's concave down the whole time. We can also see that the rate is decreasing the whole time. So we know quite a bit of information about this. So now when we make a tangent line approximation for the radius, this number is not the radius. This number is the change in the radius, which means that's our slope. So we already know the slope. And we know the points 5, 30. So 5, 30 is our points. 2 is our slope. So we do y minus y1 equals slope times x minus x1. And booyah, equation found. We can add 30 to the other side and get y equals 2x minus 10 plus 30 plus 20. Then you just plug in 5.4 to figure out the tangent line approximation. If you do that, you get 10.8 plus 20, 5.4 times 2, and you get 30.8 for the approximation or estimate of what the radius is. Now we get this question like, is it greater or less than the true value? And the key here is to realize that since our rate is always positive and we're concave down looks like this. If our rate is always positive but it's getting smaller and smaller, we're on this part of the graph. And if I draw any tangent line, I'm going to be over approximating my value. Anytime we have concave down, if I draw a tangent line, I'm going to be over approximating my value. And you never need to memorize these things because you can freaking draw them. If you draw a tangent line, it's over. Chillin'. So this is an over approximate. All right, B. There's some really meaningful chat going on there. Thanks, first period. Find the rate of change of the volume with respect to time when t equals 5. So this is going to add a wrinkle to the question. We have this volume equation. If I take the derivative of this volume equation, I get dv dt, which is the rate of change of the volume, equals 4 pi r squared dr dt, which is the rate of change of the radius. Then you just plug in all the stuff you know, and you know a ton of stuff. You know r is 5, so you get 4 pi 25, and you know dr dt is 2. And booyah, easy related rates, 200 pi is our, in units, feet cubed per minute, is our rate of change of the volume. So it's a related rates question, but it's a pretty baby related rates question because there's no product rule. The things that are plugged in are pretty easy and given to you and blah, blah, blah. All right. Next part says use a Riemann sum with 5 subintervals to approximate the integral from 0 to 12. All right. So this one isn't too bad either. To do this, all you do is, since we're picking the right subintervals, we're going to use these as our heights. And we're going to just multiply the first width, which is 2, from 0 to 2, by 4. And then we're going to add the next interval, which is 3 wide, times the right interval, which is 2, plus the third interval, which is 2 wide, times the right, which is 1.2. The fourth one, 4, from 7 to 11, times the right interval, which is 0.6. And lastly, plus 1, that last one's not very wide, times 0.5. And you just add all these together, and you get that value. What is it? 8 plus 6 is 14, plus 2.4 is 16.4, plus 2.4 is 18.8, plus 0.5 is 19.3. And what this is it's measured in feet, because it's the integral of feet per minute. And it's the change in the radius. In the radius from t equals 0 to t equals 12. And so the radius is getting bigger over that time, and the amount it gets bigger by is 19.3. We don't know the radius at 0 because we only know the radius at 5, so we don't actually know what it ends up at in that question. So we just know its change, and that's what the integral gives us. All right, so that was C. And D says, is your approximation in part C greater or less than the integral from 0 to 12? This is some gravy. The last one in the previous question was really hard. This one's not at all hard. If we pick the right value on the interval, it's always less than the left value. So we're always under approximating. Cool. Under approx, right is smaller. And we have this extra information that we should provide in our explanation, which is that the graph is concave down. So I know Right is the smallest. There could be a weird case where, like, in between 0 and 2 at 1, it could go up to, like, 77 or something like that, and that would make our assumption, weirder. Or maybe it could go way down to, no, instead of that, we're going to go down to negative 1 million or something. Uh, that could happen if it didn't say it was concave down everywhere on that interval. And that's why we have to include that as part of our exclamation. Wait, isn't it 30 squared instead of 5 squared for the radius? What did I goof? Isn't it 30? Oh! Did I goof? Wait, where did I goof that? Because, yes, the radius is 30. Did I square 5? Oh, did I mess up the volume one? Oh, sad panda. So sorry about that. So, going back to that, what was that question? It was 4 pi r squared drdt. I was just plugging in to solve for dvdt. R should have been 30. So this should have been 900 times 4 pi times drdt, which is 2. Absolutely. Yes, that should not have been the answer I got, and should have been, 7,200 pi? But the units were right. It is in feet cubed, uh, because it's, or feet cubed per minute, rather, because it's volume rate change. So yeah, thank you. I goofed and plugged in time instead of radius. Don't do that. Don't be like me. You only get half the credit for the question if you plug in the wrong value for the answer. Oopsie daisy. Alright, that was 3 FRQs. I'm pretty drained, so I'm going to give myself a break and give you work. Haha. Lightning round. 3 integrals. Go. So yeah, thank you for correcting me on that one. I goofed. Just a little hint: anytime I assign those free response questions, you can always Google them. So you probably know I'm wrong if you did that. But yeah, are you gonna do the sign in? Yeah, I linked it already earlier. It's on my homework calendar, and I'll link it again after all this. Basically just says what's your name, what period you in, which class session are you showing attendance for. I think that's first, and then name, and then period. So I can organize it in the Google Drive spreadsheet, which is the reason I'm doing it that way, because I like spreadsheets, because our gradebook entering is also a spreadsheet. And then it asks you, like, did you watch more than 30 minutes of the live stream? And if you did that, then I give you credit. I'm probably going to give credit for some assignments also. I have to be judicious with how I do all this, because I can only grade you for an hour and a half of work a week, which is hard. That's why I'm hoping we go pass fail. As per normal, please holler at me with a done when you think you got all these. These 2 lightning rounds are meant to give you questions that look kind of similar but have very different ways of solving each of them. So, see how this goes. There are a few different ways to solve each of these also. So. Just a hint to Rooney that there might be some shortcuts on some of these. Oh, do I have to change that last one to be possible? Yeah, let's do that. I believe that makes it possible. Fixed. if you were running into some problems in question 3, it was because as it was, would struggle heavily in solving that. But with a nice little square root on the bottom, weirdly that makes it easier. You know you've entered math darkness when adding a square root makes it easier. Oh, Josh, I just realized is your Uncle Rick a very successful and maybe misunderstood scientist with a potty mouth? Maybe misunderstood is the wrong descriptor for that. Up to 4 duns. We'll wait till it's like 6 or 7, and then we'll start mobbing these. All right. I think I'm going to start taking a peek at these. Every one of these could be approached with u substitution. The first one, if you made u equal to the bottom, du was almost the top. It was actually negative du, which means this integrated to the negative natural log of the absolute value of cosine of x plus c. And this, if you look up, is the integral of tangent of x, which was that problem. Our second integral, you could make u the bottom. Or you could rewrite this as the integral of cotangent of x times cosecant of x dx. Because 1 over sine is cosecant, cosine over sine is cotangent. Because if you do this play, you maybe know that this is just the integral of negative cosecant of x dx, and you're chilling, you're done. But you didn't have to do this. You could have said u equals sine of x, du equals cosine of x dx, booyah. And we're just integrating u to the negative 2 du, which integrates the u to the negative 1 over negative 1 plus c. And then you chuck a sign in, and you get exactly the same answer. Sine to the negative 1 is cosecant, and a negative because of the over negative 1. So either way gets you to the promised land here. There are a few different ways to do this next one also. Let's see if you like my preferred way. You may know sine squared x plus cosine squared x equals 1. If you know this, you know that 1 minus sine squared x equals cosine squared x. Which means this problem could be rewritten as cosine of x over square root of cosine squared x. Which means this is the integral of 1. So it's just x plus c. So that's kind of fun. You could have also done this with inverse trig and u substitution. If you did this with inverse trig and u substitution, you should have gotten the inverse sine of sine of x plus c, which is x plus c also. So, yeah. How did people do on this? Were there people getting all of these right? Quite a few of these had some tricky parts. So I was kind of curious how people did on this. Because our last round is limits instead of integrals. We did a lot of derivative stuff today. Three out of three? Nice, nice. 1 out of 3, 2 out of 3, okay. 2 out of 3 is not that bad. I wouldn't be too sad about that. Those were a little bit tricky. Cool. This is the extra time. Time permitting. 3 different limits. Why does the first one have ln in it? Because the only way to do it is to do u substitution with u equal to the bottom, so we have a 1 over u to u sort of situation, and so we have to use ln. The other 2 problems there were different kinds of situations, because we ended up having a u squared on the bottom, in both the second and third one, which gets rid of the use of ln. Because we just integrate to the negative 1 or that sort of thing. But yeah, seriously, don't feel bad if you got a 2 out of 3. 2 out of 3 is solid. 3 out of 3 is awesome, but 2 out of 3 is pretty good. So these are our last 3 questions that I have prepared for today. And then I'll repost the link to the live stream attendance doc. This thing. There's a recommended practice posted on there that I will be going over Thursday with 3 free response questions. You can Google the answers as per normal. If you know how to Google, you just type in like the first sentence or something, or copy it or whatever, and usually it'll pop up with the free response question answers like right away. First link. So pretty easy stuff. All of these have something in common. So if you figure out what that is, you can probably solve all of them relatively quickly. And I assume Daikun's not in chat, because usually we get the answer from him when I drop things like that. Yeah, TJ, I'm going to have these at the same time. Because I have 3rd and 4th period calculus, I can go during the 1 to 3 hour. So I'm probably going to have them at 1. 1's a good time for me. I am back to waking up before 1 p.m. I had drifted later because of the food poisoning, because I was up all night. And I'm back now, so I can do 1 p.m. Is this a bad time for you, TJ? Sorry. If you have something else, it's okay. Wednesdays are actually at 2 p.m., but that's during math. I don't know if that's a problem for you. Let me know when you're done, / I'll probably go over these in a couple minutes anyways to see how people did. Little hint, the technique that is used to solve like all of these starts with L. Oh, you sometimes have forensics, okay. the last one's doable without anything extra, though. Is it? Or is it shady as can be? Oh, the last one's a little bit evil, so I apologize. Yeah, no problem, TJ. If you can stop by, that's great. If you can't, that's okay too. You're gonna have no problem earning that math tutoring credit. I appreciate your help. Yeah, number 3, the third one, the third bullet point, is evil. So, we'll see if you catch on to the evil. Oops. Alright. Let's take a peek. The first one, you could factor this. Because if you plug in 4, you get 64 minus 32 minus 32, which is 0. And 64 minus 68 plus 4, which is also 0. So this is 0 over 0. So we can factor this, or the better play, we can L'Hopital's this. If we L'Hopital's, now we can plug in 4, and this is gravy. 24 over 3 times 16 is 48, minus 17 is 31. Boosh. I'm sure glad I didn't try to factor this. That looks a lot easier. Alright, second one. If I plug in 0, I get 0 plus 1 minus 1. That's 0. And 1 minus 1. That's 0. L'Hopital's. Cosine of x plus e to the x is the derivative of the top. 2 times cosine of x times negative sine of x is the derivative of the bottom. Remember, you have to chain rule those sort of situations. This is like cosine of x squared. And the minus 1 goes away with its derivative. Now if I plug in 0, I get 0 on the bottom, and I get 1 plus 1 on top, so this is undefined. 2 over 0, no good. Undefined. And last one, if I plug in infinity, what do I get? Well, on top I get infinity, because something between negative 1 and 1 plus infinity minus 1 is infinity. But on the bottom, I get negative 1 to 1 for cosine squared x, but if I subtract 1 from that, sometimes it's 0. And when you divide by 0, it's trash, so this is trash. This is a really weird question. And it's trash because of this. If you got infinity, you were really close. If this was cosine squared x plus 1, you would have been right. But because it's minus 1, there are actually some spots where we're dividing by 0 that happen every single period, and that's bad. So this thing's undefined all the time. It's kind of like a tangent graph, and it's hogwash. So we actually ended up with one answer and 2 undefines on this limit section. All right. Last little details. I did post an assignment. It's another like 3 FRQ question sort of thing. I am going to be collecting them at some point in the future, but I don't have a setup for that now, nor do I know how I'm going to be doing that. I might have like 1 graded assignment per week and 1 graded stream. I'm not sure how we're doing this because I'm only allowed to assess you on an hour and a half of work. But I recommend doing that practice. I'll be going over it next stream Thursday. I guess next stream is Wednesday when we're just going to be doing a bunch of practice at 2 p.m. But on Thursday I'll be going over that. And I'll see you then. Keep practicing. Keep getting smarter. And be ready for that AP test. Later, dudes. Hour and 15 minutes. Man, I said I was going to go shorter, and I did not. All right. Bye bye.